Welcome everybody. Thank you for joining me. Wow, automatic door. Thank you for joining me. I would like to start with a little story today. So, once upon a time, there was a programmer, and he had about 10 to 15 years of experience, and he was happily coding away. Until he suddenly noticed something. He noticed that the debugger had become an important tool in his toolbox. And this, while he was barely scratching the surface of its capabilities. So he decided to become more proficient in using this tool. He read a lot of articles, he read a lot of blogs, he watched a lot of YouTube videos, and just plainly started clicking around in his IDE to uncover more features. In this journey, he learned a lot, and he decided to create a presentation. This presentation. My name is Bouke Nijhuis. I'm the CTO at a company called Sync ICT. You can easily reach me on Twitter on the handle that is currently on the screen. And the title of today is Improving Your Skills with the Debugger. There are 5 topics I would like to talk about today. And the first one is breakpoints. I assume everybody knows that a breakpoint pauses the execution of your program. But there is more to breakpoints than meets the eye. I'm going to show you what's more. The next chapter will be stepping operations. Again, I assume everybody knows about the basic stepping operations, but I would like to talk about the advanced ones. In the middle, we're going to talk about evaluating expressions. So while debugging, you see the variables and their values, but I would like to go one step further. I would like to see the outcome of expressions. The former last topic will be hot code swapping. Hot code swapping is changing code in a running program without restarting it. And the last topic will be remote debugging. So normally when you debug a program that is started by your IDE, but it doesn't have to be the case. You can also debug programs that are started elsewhere. So I'm not only going to talk about those topics, I'm also going to show them to you. This is a live coding session. Maybe the slides already gave that a bit away. So we need a bit of code. And so I can debug this code to show off features of the debugger. So I created a little program called Hello World. Maybe you heard of it before? OK, now, just to be sure, I'm going to demo it anyway. If I run the program, it prints Hello World to the console, like a proper Hello World program should. But I added a little twist. If you provide a command line argument, in this case Bouke, my first name, it will not print hello world, but hello Bouke. Those are the 2 features of this fantastic program. How does that look code-wise? So we have a hello world class with one field in there. It's called default value, it's a string, and it contains the word world. Then we have the main method, the entry point of our application. The first thing it does, it calls the create message method, which is over here. It passes the command line arguments, and then inside the create message method, there is one variable called name, which defaults to the default value, world. Then there is a check if there are any command line arguments, and if this is the case, it will update the value of the name variable to the first command line argument. Then we use a string.format to create a string. The string will always start with hello, then a space, the value of the name variable, and then an exclamation mark. The string is returned and put in the message variable over here. Then the last thing that we do is we print the message variable to the console. So no rocket science here. But we don't need rocket science to show off features of the debugger. A few more small points before I really dive into the first topic. And the first one is, during this presentation, I will use Shift a lot. This is search everywhere in IntelliJ, and then if you type in something that you want to do, in this case I want to edit configurations, something I will do later in this presentation, I press enter and it will perform this action. So you will see me doing this many times during the presentation. And then the last point is, how do you actually debug in IntelliJ? That part is easy. First, you click in the gutter. The gutter is the area next to the line numbers. Now, if you do that, let's click over here, you get a nice red dot. This red dot, of course, is a breakpoint. The next thing you do, you go to the green triangle up here, you select the second option, debug. And if you do that, IntelliJ will compile your code, start up your program, start up the debugger, and attach the debugger to your running process. More about this later. So now we can dive into the first topic, breakpoints. During the introduction, I told you I assume everybody knows that a breakpoint pauses the execution of your program. Ta-da! Now I'm pretty sure that everybody knows. A breakpoint pauses the execution of your program. But I also told you there's more to breakpoints, so let's find more. First thing that we're going to do, we're going to right-click on the breakpoint. And if you do that, you get a nice little pop-up. Let's quickly discuss the options in the pop-up. The first option is enabled. By default, breakpoints are enabled. And this is a great default, because we want our breakpoints to do something. But if you temporarily want to disable a breakpoint, you can just uncheck the box in front of enabled, and it will be temporarily disabled. In the past, I would delete breakpoints and recreate them, but nowadays, I just disable them. The second option is suspend. Again, a great default, because by default, we want a breakpoint to suspend or pause the execution of a program. But not always. In a few minutes, I will give you a demo in which I will not suspend the execution of my program. Behind suspend, there are two radio buttons. The first one is all. All means it will pause all the threads in your program. And if you select thread, it will only pause your current thread. I never use this option, but I can imagine if you're doing thread programming that this can be pretty useful. Then the first option is condition. Condition is used to create conditional breakpoints. A conditional breakpoint is a breakpoint that will only be enabled when its condition is true. Now let me give you a small example. Let's say name equals, typing is hard, especially when people are watching. Bouke. This is incorrect because name equals the world, the default value. If I press done, the first thing that you notice is that there's a little question mark here under the on top of the blue, on top of the red dot. That means it's a conditional breakpoint now. The condition evaluates to false, and therefore I expect the program to run without pausing. Let's run the program. And as you can see, it printed hello world, and it did not pause. And that's because the condition was untrue, and therefore the breakpoint was disabled. Let's change the condition to something that is true. So this is true. Now I expect the breakpoint to pause, because its condition is true. So this is a conditional breakpoint. And this is really useful whenever you have a breakpoint that will be hit many, many times during the execution of your program, but you're only interested in very specific cases. If you choose your condition right, it will only pause in those specific cases. So, yeah, let's have a look at this small pop-up again. During the introduction, I told you there's more to breakpoints, and look at that. There is the more. If you click it, you get an even bigger pop-up with a lot of options. Unfortunately, I don't have enough time to discuss all of them, so I'm going to focus on a really small part of the screen. But before I'm going to do that, I would like to share something with you. In the past, when I started investigating an issue or a problem, the first thing I would do, I would put system out print lines in the code. And I do this for two reasons. I did this for two reasons. First, I wanted to know which parts of the code were executed, and secondly, I wanted to know the values of the variables. And I don't think I'm the only one with this reflex. Quick raise of hands. Are there other people in the room who have the same reflex? I see, oh, okay, 50% of the people. I'm not alone, that's good to know. I don't think this is a bad reflex. I think this is a fine reflex, and it really helps you get the bearings on your problem. So I think it's great, but there is one big disadvantage. Sometimes, and only sometimes, I forget to remove those print lines, and then they end up in PRs or even worse in production. Quick raise of hands. Who does the same? Less people. Impressive. There are people in the room who don't forget to remove them. That's pretty good. But if you are one of the people who do forget to remove them, there is a solution for the problem. Wouldn't it be nice if there was a way that we can have all the advantages of the system out print line, but not this big downside of forgetting to remove it? And as it turns out, there is. Let me first clean up a little bit, things we don't need anymore from previous demos, so like this. So the thing that I use nowadays is evaluate and log. I call this a logging breakpoint. So what I normally put in a system out print line, I nowadays put over here. So I would write something like this, right? This look familiar? This is what you put in the system out print line. Before I'm going to press the done button down here, we're emulating a print line. Do we want our breakpoint to suspend or pause the execution of our program? We do not. We just want it to print something and to continue. So we're going to uncheck this box. I'm going to press done, and I'm going to restart the debug to see what happens. But before I do that, notice that the red dot became a yellow dot. A yellow dot means it does not suspend or pause the execution of your program. So if I restart the debugger, hey, something new happened. This line is new. You see? So we used a breakpoint, a logging breakpoint, to do logging. This has the advantage of a system out print line, but not the disadvantage of ending up in a PR or production, because a breakpoint is not code, and therefore it will never end up in a PR, or it will never end up in production. So nowadays I use logging breakpoints to scratch that itch to get more information when starting investigating. But I hear people thinking, this is nice, Bouke, this is a nice feature, but it's a lot of work. First I have to left click in a gutter, then I have to right click on the red dot, then I have to click more, I have to uncheck the suspend, I have to check, evaluate and log, I have to fill in the expression, and I have to press OK. Those are 7 steps. This is too much work. I'm never going to do this. I'm just going to do the print outline, the print line like I always did. I totally agree with you. This is far too much work. Let's see if we can find a faster way. Now, luckily, IntelliJ helps us out here. If you select the thing that you want to log, and then shift-click in the gutter, like this, it creates a non-suspending breakpoint for you. It already selects the evaluate and log, and it pre-fills the expression because you selected it before you shift-clicked. And this is already a lot better. Let's see if it works. If I run the debugger, now, it works. It printed world. Now, there are I'm pretty happy with this feature, but there are 2 things I would like to improve. The first one is I don't see the name of the variable. So if you use a lot of those logging breakpoints, you don't know which value belongs to which variable, which is annoying. And furthermore, I prefer to use the keyboard as much as possible. So actually, I want to do this without using the touchpad or the mouse. Now, unfortunately, I could not find a way in IntelliJ to do this, but I decided to fix this problem myself. So what I created is a plugin for IntelliJ. So first I select the thing that I want to log, like this, and then if I press the appropriate shortcut keys, a logging breakpoint is created for me. If I now run the debugger to see if it really works, you see it first prints the thing that I selected, the expression, and then it prints the value within square brackets. Now, with this plugin, there is no reason left of using the old way of print lines. This way is faster, and it doesn't have the big disadvantage of the old way, using a system out print line. After this presentation, I will share the code of this plugin with you so you can use it in your own projects. Actually, I can do one better. I will share a link to a blog in which I explain how I created the plugin. It will also contain a link to the source code so you can use it in your projects as well. So 2 more things I would like to talk about. Let me look how I'm doing for time. Excellent. Those 2 things are actually things I did not know before I started investigating for this presentation. So, did you know that you can drag and drop breakpoints? I did not. And this is really useful, especially when you have a complex breakpoint, containing a logging expression, containing a condition, and maybe more of the other stuff I didn't talk about. So in the past, I would just delete it and recreate it in a new spot. Another thing I learned is that you can restore breakpoints, because sometimes I click on them, and then I never remember, should I right-click, should I left-click, so I click, damn, breakpoint's gone. So I do Shift-Shift, remember, I introduced Shift-Shift, search everywhere. I type in restore breakpoint or part of it, and then you wait, and bam, it restores the breakpoint. And again, this is great for complex breakpoints, if you accidentally delete them. So this is actually everything I wanted to tell about breakpoints right now. Let's continue with the second topic, which is stepping operators. So during the introduction, I told you I would like to talk about the advanced stepping operators, but first we have to talk about the basic ones, because the advanced one advanced ones built upon the basic ones. So there are 4 basic stepping operations. And let me start the debugger real quick so I have a visual cue. One moment. So the 4 basic step operations are over here. I'm quickly going to discuss them. And the first one is step over. And step over does what it says on the can. It executes your current line and then goes to the next line. It steps over the current line. Let me demo that quickly to you. If I put the breakpoint over here, restart the debugger, and I click step over, the blue line, I didn't explain what the blue line was. The blue line is your current execution point. This is where currently your program, the execution of your program is paused. So if I click step over, the blue line will go from line 8 to line 9. It executed everything on line 8, including the create message method, and then went to line 9. Then the next one is step into. You can use step into whenever there is a method call on your current line. So currently on line 8, there is a method call to create message. If you click step into, it will pause at the first line inside that method. So it will pause at line 13, like this. Then we have step out, which is the opposite of step in. It will execute the method where it's currently in, and then go back to the caller of the method, and then pause over there. So the blue line will go back to line 8 if I click step out. There you go. Interesting thing, the blue line is currently at line 8, but now we're in a point of time in which we already executed the create message, while a minute ago, the blue line was also at line 8, but we were in a point of time before we called create message. More about this thing later. Just remember, the blue line isn't a specific indicator of where you are, it's more of an approximation. And then the last one is return to cursor. So I put the cursor over here. If I click the button over here, or use its appropriate shortcut key, it will execute the code until it will hit the line that contains the cursor, in this case line 15. So if I click it, it executes code and goes to line 15. A faster way to do this in IntelliJ is to control-click a line number. If you do that, it automatically runs to that line. So that's run to cursor with 1 click less. So those were the 4 basic stepping operations. Let's go to the more advanced stuff. And I would like with a category of stepping operations called the force operations. So the first one is force step over, this one. Notice that this toolbar this is not the default toolbar. I changed it to have all the operations in here that I want to talk about. And if you also want to change it, you can do that over here. So the first one is force step over. I just told you step over does what it says on the can. It executes the current line and goes to the next line. And this is true unless there's a breakpoint in between. So I created a breakpoint at line 15 in the create message method. If you use step over, it will execute the create message method. So if I do step over, it will not go to line 9, but to line 15, because there was a breakpoint in between 8 and 9. So if you don't want this behavior, then you can do a force step over. Then it will ignore all the breakpoints in between. So if you do this, oh, sorry, I did it twice. If I click force step over, it ignores the breakpoints in between and just goes to the next line. Now, something very similar is going on with force run to cursor. Force run to cursor will execute your program and go to the line where the cursor is, unless there are breakpoints in between. If you want to skip breakpoints in between, you use force run to cursor. And then a different force one, the force step into. So I've just told you, when you use step into, you need to have a method call. Sorry, preparing the demo and talking at the same time. Pretty difficult for a guy. So if you want to use step into, you have to have a method call at your current line. Now, the current line is line 9, and there is a method call, print line. So I expect when I use step into that it goes inside the print line method, but it does not. And that's because step into only works for your own methods. It doesn't work for third-party methods. So if you really want to step into a third-party method, like print line, part of the SDK, then you have to use force step into. And this is really useful because we normally don't expect our bugs to be in our code, right? We expect them to be in other people's code. So with force step into, you can also debug third-party code. Let me clean up a little bit. Okay, those were the 3 force stepping operators. The next one is smart step into. Now, before I can demo that one, I have to change the code a little bit. What we're going to do, we're going to inline the message variable. What does that mean? If you inline a variable, you get rid of the variable, and this selected thing will go over here. Now, the easiest way to do that in IntelliJ, to let the IDE do this for you, you use the right keyboard shortcut, so you click enter a few times, and ta-da! The message variable is gone. The output of the code is exactly the same. The program didn't really change. I just removed an obsolete variable. But this enables me to show off smart step into. Smart step into can be used whenever there are at least 2 method calls on one line. Now, currently on line 8, there is a call to create message and a call to print line. So now we have 2 method calls. It is also enabled by default in IntelliJ, so you don't have to use this button over here. You can also use the normal step into. IntelliJ is smart enough to count, and if it counts 2 or more method calls in one line, it will use smart step into. If you click the button, I now have a pink box that I can move around with the arrow keys. And if I use I can select the one I can select the method I would like to step into. So currently it's on create message. I press enter, and it goes to the first line of create message. In the past, before we had smart step into, it would work from right to left. So if you had like 5 method calls on one line, it was a lot of work to get to the first line of the first method. And that brings me to my last advanced stepping operation and my favorite advanced stepping operation, and that is resetting or dropping frames. So up till now, all the stepping operations we talked about were going forward in time. What does that mean? A program has a starting point and a termination point. And all the things we talked about went forward. Step over, step into, step out, run to cursor. They all went towards the termination point of your program. Reset or drop a frame does not. It goes the other way. It enables us to time travel. It enables us to go back in time. That sounds interesting, right? So let me give you a little demo. Currently, in the bottom part of the screen, you see the debug toolbar. Is it visible for everybody? Because I got the advice that the lower part of the screen isn't really visible. So is it good enough? Okay, nobody complains, then probably it's good enough. To be able to explain dropping frames, we first need to know what a frame is, right? So to be able to explain that, we have to talk about stack traces. And I assume everybody knows that a stack trace is built up out of method calls, right? We have the main method calls another method, calls another method, calls another method. Another word for an item in a stack trace is a frame. So currently, we have a stack trace with 2 items, 2 frames. If I drop a frame, I will drop the topmost item of the stack trace, because it's called a stack trace. It's a stack, so if you do something, you have to work from the top. So if you drop a frame, you remove the top item of the stack trace. So you can do this by clicking over here, or the button over here. If I'm going to click the button, the blue bar will go from line 12 back to line 8. Let's do it just to show it. Well, it went back. Interesting thing. Currently, we're in a point of time in which we still have to call the create message. Well, 30 seconds ago, we were inside the create message. So debugging-wise, we have been time traveling. We went back in time. And this only works within the context of the JVM. You cannot do if you do a database transaction and then drop a frame to go back in time, the database transaction will not be rolled back. But everything within the context of the JVM will go back in time. And this is really useful when you're debugging somewhere near the termination point of your program, but you would like to debug somewhere near the starting point. In the past, I would put a breakpoint over here, restart the program, and start over. But nowadays, I just drop a few frames, and I go back to the beginning point of the execution. And it becomes even more powerful if you combine it with hot code swapping or remote debugging. So more about dropping frames later. Let's go to the third topic, evaluating expressions. English is a difficult language. So the expression that I would like to evaluate is this one. During the introduction, I told you we see the values of the variables, but I would like to go one step further. I would like to see the outcome of expressions. Now we're going to use this expression to do this. I'm going to put a breakpoint over here. I keep misclicking. I put a breakpoint over here. I'm going to restart the debugger. And the first way I would like to talk about, and the fastest way I know to evaluate an expression in IntelliJ, is quick evaluate expression. So you hold the Option key if you're on a Mac. If you're on a Windows or a Linux machine, you hold the Alt key, and then you hover over the expression that you would like to evaluate. And as you can see, it became underlined and the color changed a little bit. Then you left click and you get this little pop-up. Let me click here. And now you can see this expression evaluated to hello world as we expected. So this is the quickest way I know. But the name quick evaluate expression implies that there also is a normal evaluate expression. So let me show you that one. First I select the thing that I want to evaluate, so this one. And then you click the little button over here, or the shortcut key, of course. But if you do that, a pop-up occurs and the expression is pre-filled. Now you press enter and it evaluates the expression for you. And this is great. It's a bit slower than quick evaluate expression, but the interesting thing is now we can play with the expression. So what I can do, I can change name into a string containing my first name, Bouke, press enter, and now you see it doesn't say hello world anymore, it says hello Bouke. So you can re-evaluate with only an enter. And this is really useful when you know there is a bug somewhere, but you don't know exactly how to fix it. Let me give you a little example. So the thing that I want to do, I want to print hello space 1 dot or comma, I don't really care, but with exactly 2 zeros and then an exclamation mark. So the first thing that I'm going to try is of course just filling in 1.00. And then the outcome is 1 0, almost there, but I want 2 zeros. Now, as we all know, I have to play with this thing over here. Of course, I could be reading the documentation, but I'm a lazy developer who reads documentation. It's far more fun to try out till it works, right? That's where the fun in our job is. So I'm just going to try to see what happens. So let's try n from number. /n, that's not good. The d from decimal. Illegal format conversion exception. This is not going the right way. Integer? Nah. Okay, that doesn't work. While trying out these examples, I remember, I think I have to give the number in the right format, and then the formatter is smart enough to apply this format. Okay, still an exception. Wait, I think I have to add an F. Hey, the background became white again. That's normally a good sign. Hey, 1, 2, 11 zeros. But now I know how to fix it, right? This 11 should become a 2. Bam, desired outcome, 2 zeros. Did you notice what just happened? I tried out about 6 fixes in under a minute. And this is the power of evaluate expression. When you know where your issue is, and you want to try out a lot of fixes in a short amount of time, use evaluate expression. So, one last expression I would like to evaluate, and that's a very special one, namely a stream. Streams are notoriously hard to debug. So the thing that I'm going to do, I'm first going to try to explain the stream to you in words. Then I'm gonna show you, gonna explain the code. And then lastly, I'm going to show you the proper way to debug streams. Let me restart the debugger to see if it really works. Yeah, oh, cool. So over here it says simple right shifting algorithm. What does that mean? If the input of the program is, of the stream is A, B, C, the output would be B, C, D. So this stream takes every character in the string and moves it one position to the right, alphabet-wise. How does that work in the code? Now first we have a name variable, which is a string. We apply the gars operation that takes every character in a string and transforms it into an ASCII code, so we get an int stream. Then we increase all the ASCII codes by 1. We transform all the increased ASCII codes back into single character strings. And lastly, we join all the strings together in one big string again. So explaining this wasn't really hard, but also not really simple. Wouldn't it be nice if there was a way that we could see the values flowing through the stream? You cannot do this with conventional debugging methods. It just plainly doesn't work. But luckily, IntelliJ helps us out there. If the debugger pauses on the line containing a stream, this little button over here becomes available. If you click it, you get a pop-up with 4 tabs. Those 4 tabs correspond to the 4 operations in the stream. Remember, the first one was taking every character in a string and transforming it into ASCII codes. And look over here, I have 5 ASCII codes. The next one was increasing the ASCII codes by 1. On the right, the numbers are 1 higher than the numbers on the left. The third operation was transforming the increased ASCII codes back to single character strings. On the left, increased ASCII codes. On the right, single character strings. And lastly, we would join all the strings together in one big string again, and we get this unpronounceable word. So this is the power of the stream debugger in IntelliJ. The next time when you have to debug a stream, use this fantastic tool. It will save you a lot of time, I promise. Okay, enough about evaluating expressions. Let's go to the 4th topic, which is hot code swapping. First, I have to do a little bit of cleanup. So I'm going to put the breakpoint over here. The thing that we're going to hot code swap is this string. So during the introduction, I told you hot code swapping is the changing of code in a running program without restarting it. So what I'm going to do, I'm going to change hello into bonjour, the French version of hello. If you do that, you have to tell IntelliJ to recompile the class and to put it in the JVM. The easiest way to do that is Shift-Shift, search everywhere, there is it again, and type in the first characters of reload changed classes, RCC. If you do that, it will reload the class for you, put it in the JVM, and then if you finish the execution of the program, it says bonjour world. You see what happened? I changed code in a running program, but I did not restart it. This is really useful, and I will explain in a few minutes when I use this mechanism, but first I would like to talk about its limitations. It has a few limitations, and the biggest one, in my opinion, is the fact that you're not allowed to change code in your current method or frame. What does that mean? Let me give you a little demo to make this more clear. There's a reason I put this breakpoint over here, because if I put it over here, it will not work. So now I'm going to change bonjour into guten Tag, the German formal version of hello. Again, I'm going to reload the changed classes. We wait a few seconds so the class can be reloaded. And if we now finish the execution of the program, hey, it still says bonjour, but it's guten Tag over there. So hot code swapping does not work if the breakpoint is in the same method as where you want to change code. And this is really annoying, because normally I'm debugging, so I'm stepping through the code, I find the issue, and I want to change something near the issue. In most cases, I have to fix it somewhere in the same method, so this is pretty annoying. So let's see if we can find a workaround. So I'm going to restart the debugger. I'm going to change guten Tag into hello, the Dutch version of hello. Again, we have to reload to change classes, of course. And the workaround for this limitation is, of course, dropping frames. If you drop the frame, the blue bar will go back to the main method. So my current execution point is in the main method. I changed code in the create message method. So I did not change code in the current frame or method. So by using dropping frames, you can circumvent the limitation that you're not allowed to change code in your current method or frame. If I finish the execution, see, it says hello world. So this is really useful whenever you have an issue that you cannot reproduce with a unit test. So in most cases, I work like this. I have an issue. I write a unit test. I run the unit test. It becomes red because I didn't fix it. I write a fix, and if the fix was correct, the unit test becomes green, and in most cases, problem solved. But sometimes I have issues that I cannot reproduce with a unit test. How do I work in that case? I create a fix. I restart the program. I do manual actions because I don't have a unit test that I can quickly see to use to see if the fix is right. And if it doesn't work, I start over. Now, this is workable, but nowadays, what I do, I write a fix. Instead of restarting, I use hot code swapping to implement the fix, and then instead of doing manual actions, I drop a few frames and then I step forward again. Now, this in itself is already faster, but the real big advantage is in the fact that I don't have to leave my IDE. I don't have to leave my IDE to do the manual action somewhere else. Normally I have to do that somewhere in a browser or in a desktop application. And that's annoying, all those switches. With this technique, you can stay in your IDE, and it makes the debugging and the trying out of fixes easier. And it becomes even more powerful if you combine it with remote debugging. I have 10 minutes left, is that correct? Nobody knows? Yeah, thank you. Okay, last topic, remote debugging. So during the introduction, I told you remote debugging is debugging a program that is not started by your IDE. Up till this point, all the debugging that we did were in programs that were started by the IDE. But now we're going to do something differently. What we're going to do, we're going to attach the debugger from IntelliJ to a program running in the terminal. And this is what remote debugging is. So somewhere near the beginning of this presentation, I told you about the fact that IntelliJ compiles your code, starts up your program, starts up the debugger, and attaches the debugger. So apparently, we have two important things. We have a running program, we have a debugger that tries to attach to a running program. Now, if you look really closely to the console, you can find traces of this process. This line over here is from the debugger. And it's the debugger who is saying, I'm connected to a VM, you can start debugging. And apparently, a debugger connects on localhost and some port. So now we have two important concepts. A program listening for a debugger, and a debugger attaching itself to the program. Let's start with the debugger part. How do you instruct a debugger to connect to a running program? Shift-Shift, search everywhere, and then you type in part of edit configurations. If you do that, you create a new configuration by clicking on the plus or the appropriate shortcut key, and then you type in remote. The thing that you want to use is a remote JVM debug configuration. So this one. Now the first thing we do, we give it a name we can recognize. So let's say Spring remote. There are some values, default values, and those default values are great. By default, the debugger in IntelliJ tries to connect to a program listening on localhost 505. So how do I make my program or my JVM listen for a remote debugger on this specific port? Now, luckily, that part is easy. You copy this line, you go to your program, and you paste it in the right spot. That's over here. Notice that I use double quotes because there is an asterisk in there over here. So this thing, shells tend to expand those asterisks and then it will fill. So use double quotes. And if you do this, hey, something new happens. Look over here. This is new. So apparently adding those command line arguments changed something to my program. And my program started listening for a debugger on port 5005. But unfortunately, my program was so fast, I didn't have any time to attach a debugger. So we have to make one more small change. Somewhere in here it says suspend is no. This should become suspend is yes. If you do this, the program starts up, starts listening for a debugger, and pauses. So the program is now waiting for a debugger to attach itself. Let's attach a debugger. Remember this. Not remember this. Remember that everything on this screen is instructions for the debugger. We did not actually start the debugger. Those are just instructions. So the easiest way to start the debugger with these instructions is again Shift-Shift, search everywhere, and then the name of the thing that we just created. So this one. And notice that it says over here, debug, to debug, press enter. I'm going to press enter. Hey, the debugger in IntelliJ is debugging something, right? You see the big blue bar. That thing that is debugging has its input argument Bouke. Look over here. This program has its input argument Bouke. So the debugger in IntelliJ is now debugging the program in the terminal. Everything you can do when debugging locally, you can also do when debugging remotely. So let's do some advanced stuff. Let's change hello into goedendag. Let's use hot code swapping. And remember, you're not allowed to change code in your current method or frame, so we have to drop a frame as well. And let's finish the execution of the program. So, goedendag Bouke. So I just gave a demo that combined remote debugging, hot code swapping, and dropping frames. It doesn't get any more fancy than this in this presentation. So, two more things. When do I use remote debugging? There are two big use cases. I use it mostly whenever I have an issue that I cannot reproduce locally. So an issue that only occurs on a specific machine or a specific server. If that happens, I use remote debugging to connect to that machine to get more information about the issue, and hopefully enough information to create a fix. And then the second use case is trying out fixes quickly on a remote server. And this is where it really becomes powerful. So without this, the old way of working for me was create a fix, create a release, deploy the release, because it has to go to a different machine, go to that machine, do manual actions to see if it works. If it doesn't work, I start over. This is a slow and tedious process. Nowadays, I would do this. I would create a fix, remote debug to the server, use hot code swapping to deploy the fix, drop a frame and step forward instead of manual actions. And with this combination of techniques, you can really quickly try out fixes on a remote machine. So also a word of warning, remote debugging can be pretty dangerous. Don't do it to your production machine. I've just told you and explained to you that you can change code on that specific server without an audit trail. You don't create releases, so nobody knows that you changed the code. Therefore, it's pretty dangerous, and don't use it on production. Use it on different machines. I think I'm running out of time. Yeah, very good. Few minutes left. I'm not a big fan of doing questions with the entire audience, so I'm going to wrap up. If you have questions, please come to me after the presentation down here, so I will answer them individually. I hope everybody learned something new. Thank you for being here, and enjoy the remainder of the conference. Bye-bye.